Let us now learn about the diagonal theorems related to square. We know that square is a mixture of rectangle and rhombus. Therefore, the theorems that are applicable to rectangle and rhombus also apply for a square. The diagonal theorem of rhombus states that the diagonals bisect each other at 90 degree, and the diagonal theorem of rectangle states that the diagonal of rectangle must be equal. Since square derives its properties from both rectangle and rhombus, therefore diagonals of a square must bisect each other at 90 degree, and also they must be equal. So as per the theorem, the diagonals of a square are equal and bisect each other at 90 degree. This is what we need to prove. Firstly, we'll take triangle AOD and triangle AOB. AD is equals to AB because in a square all sides are equal. AO is equals to AO, which is common. ABCD is a parallelogram whose diagonals bisect each other. So we can say that OD is equals to OB because the diagonals bisect each other. Therefore, by SSS rule, I can say that triangle AOD is congruent to triangle AOB by SSS rule. Since the two triangles are congruent, therefore, angle AOD is equal to angle AOB. And since BD is a straight line, therefore, angle AOD plus angle AOB is equals to 180 degree, which implies angle AOD is equal to angle AOB is equal to 90 degree. Therefore, we have proved that the diagonals of a square bisect each other at 90 degree. Now, the second part is the diagonals are equal. For this, let's take triangle ADC and triangle BCD. Here, we know that AD is equals to BC, DC is equals to DC, which is common. Angle ADC is equal to angle BCD is equals to 90 degree because it is a square and all the angles of a square are 90 degree. Therefore, I can say that triangle ADC is congruent to triangle BCD by SAS rule, which implies that AC is equals to BD, which are diagonals of the square ABCD. Therefore, the diagonals are also equal. Now, the second part is inverse of this theorem. So, as per theorem 2, if diagonals of a parallelogram are equal and intersect each other at a right angle, then it is a square. Now, it is already given that AC is equals to BD. Given AC is equals to BD. And the angles bisect each other at 90 degree. Now, to prove it is a square, we need to show that all the sides are equal and all the angles are 90 degree. Firstly, we'll prove that all sides are equal. So, let's take triangle AOB and triangle AOD. Here we know that OD is equals to OB because it is a parallelogram and the diagonals of a parallelogram bisect each other. Also, AO is equals to AO because it is a common side. Also, angle 1 is equals to angle 2, which is 90 degree. Angle 1 is equals to angle 2, which is given. Therefore, by SAS congruency rule, I can say that triangle AOB is congruent to triangle AOD by SAS rule. Hence, I can say that the corresponding sides are equal, which implies that AB is equals to AD. Hence, prove that all sides of the particular parallelogram are equal. Now, the next part. The next part is all the angles of this parallelogram are 90 degree. Let us take triangle ADC and triangle BCD. We know that AD is equals to BC because opposite sides of a parallelogram are equal. Also, DC is equals to DC because it is common. AC is also equal to BD because it is already given that diagonals are equal. Therefore, I can say that triangle ADC is congruent to triangle BCD by SSS rule, which implies angle ADC is equal to angle BCD. But since these are consecutive interior angles between two parallel lines, therefore I can say that angle ADC plus angle BCD is equals to 180 degree. Therefore, angle ADC is equals to angle BCD is equals to 90 degree. Therefore, all the angles of a parallelogram are 90 degree. Now, since the sides are equal and every angle is 90 degree, therefore, this particular parallelogram is a square.